A good day. So we are still under applications of linear functions. The learning outcomes at the end of this, you should be able to explain concept of demand and supply curves, plot demand and supply functions, and distinguish between the types of graphs, determine equations for demand and supply. So we are going to start with demand. It says here that demand is the quantity of a product or service that consumers are willing and able to buy at a given price. Then the law of demand, there is a negative, meaning the inverse relationship between price and demand. When price increases, quantity demanded decreases. When price decreases, quantity demanded increases. A linear demand function is given as Q is equals to A minus BP. So Q being your dependent variable, Q being your dependent variable, which is your quantity demanded. So this is dependent variable, and P is your independent variable, P meaning the price. So this is independent variable. Independent variable. And then you'll notice that A, they're saying it's a vertical intercept. So this will be our intercept. And then B is our slope. So B is the slope. So if you remember, we did the slope and the linear function. So this is our slope. So with the slope, if you can remember from the first lesson, if you are given your linear function is y is equals to mx plus c, m is going to be your slope, and then the slope is given as y2 minus y1 over x2 minus x1. So this is how we solve for the slope, meaning the change in y over the change in x. So now if our function is given as q is equals to a minus bp, so it means that now our b is going to be the slope. So when we have to calculate the slope under demand function, we are going to have, the formula is going to be b is equals to the change in q over the change in p. So meaning it's going to be q2 minus q1 over p2 minus p1. So this is how we solve for the slope, or we say the gradient. And then you'll notice that the slope for the demand function is a negative. So what does it mean? It means that now when we have to draw our linear demand function, or the graph for linear demand function, we are going to have, this will be our Cartesian plane. It's going to have, the graph is going to have a negative slope. So because the q is here, so on this line is going to be my q, and on this line is going to be my p. And then you'll notice that here it says that in economics, the rule that independent variable goes on the x-axis and dependent variable goes on the y-axis does not apply. Both variables are endogenous. So meaning that here we can also have p and then the q can be here. They can swap. All right. So don't be surprised when you see p on the y-axis. Okay. So when we draw our graph, we're going to have this. If I have to draw the function for the demand, we are going to have, this will be my A. Remember, we said that this is an intercept. So that's where my graph is going to touch the Q. And then this one, it's going to be B. sorry, A over B. When we solve for it, it's going to be A over B. All right. So my graph is going to look like this. So this is what we call a negative slope. This slope is negative. So my slope here is negative B. So the slope is equals to negative B. So the slope is going to be negative. All right. And then now we move on to supply. So it says here that supply is the quantity of a product or service that producers are willing to sell at a given price. Then the law of supply, there's a positive or direct relationship between price and supply. So when price increases, quantity supplied increases. And then, so what does it mean? So this means that when the price of a good is high, suppliers want to sell more in order to make more profit. Therefore, a increase in supply. All right. And then when the price decreases, quantity supplied also decreases. So that's what we call a direct relationship. All right. So the linear function, the linear supply function is given as Q is equals to C plus dP. So D being your slope and then Q and P. So it means that in this case, my Q is a dependent variable and the P will be independent variable. And then you'll notice that the slope for this one is positive. So as I said before, when we calculate the slope here, it's going to be the change in Q over the change in P. So I am going to have, I'm going to have the slope, which is D. Okay, let me see how I wrote it here. Sorry. Did I say D? Okay. All right. So I am going to have, sorry. So the slope here is going to be D. Is going to be D is equals to Q2 minus Q1 over P2 minus P1. All right. So that's how we calculate the slope. So this is the slope. All right. If you want to calculate the value of D. All right. And then when we draw the linear supply function, the graph is going to look something like this. Remember we said that C, that's where your graph is going to start. So when coming to the supply function, okay, dependent Q is here, independent is here, in this case, according to the function, all right? Then C, that's where our graph starts. So when coming to the supply function, the graph is going to start here at the bottom. It starts at the negative side. So you will see when we do problems, what we mean when we say the graph starts, but we don't consider this part. All right. So this will be a negative C. And then this one here is going to be negative C over D. Again, you get this by solving. You'll see it. So that's where my graph touches the P and in the price. And then the slope for this one is D. So the slope, it's a positive slope if you can see it. It's a positive slope. Sorry. So that's where, and then you see here the C is the vertical intercept and the positive slope, quantity supplied is Q, and then P is the price. All right. And then here it says that note, if we need the supply function with P as the dependent variable, so if you want the P to be this side, we transform the function. So this is just an example. So let's say you're given this function Q is equals to negative 100 plus 2P, and you want P to be the subject of the formula, or you want P to be a dependent. You want P to be a dependent variable. So meaning we're going to be solving for P. So the first thing we're going to do, we are going to take this to the other side. So this will be a negative. It's going to be a negative. 2p, because when a number jumps an equal sign, it changes the sign. And I have a negative 100. So also this q is going to jump the equal sign. It's going to be a minus because it was a positive. It's going to be a minus p. And then now, so it means I have negative 2p. I'm just rewriting this so that I can be able to show you how we get to the answer. All right, now I want p to be alone. I'm going to divide everything by this negative 2. So I'm going to divide by negative 2. Just going to use a different color. So we're going to divide everything by negative 2. Whatever you do on the left-hand side, you must also do it on the right-hand side. Divide also this one by negative 2. Please note that here, there's a 1. Even though we don't write it next to a variable, there's always a 1. Most of us, we know this. If you see x next to x, there's a 1. All right. So now these are going to cancel. So this is going to cancel this one. And then this side, I'll be left with p. All right. I'll be left with a p. This will be p, then is equals to this divided by this, the positive 50. And this divided by this is a positive. 1 over 2 is the same as 0.5. Then you say p. So this is how you make p a dependent variable. So you will see from your activities, sometimes they want p as a dependent. So this is how you get to the answer. And then now let's move on to the example. So the example here, it says that a local market sells oranges. Local fruit market sells oranges. The demand for oranges is 120 bags when the price is 0. Right. So for this one, they're saying that 120 bags when what? When the price is 0 rand. So remember 120 bags, that's my quantity. So it means my Q here is equals to 120. And then when the price is 0 rand. And then they're saying that and no oranges are demanded when the price is 60 rand. So no oranges means that it's a 0 oranges. So my quantity for this one, no oranges, Q is equals to 0. And then when the price, so this means that when the price is 60 rand. Okay. And then now we move on to supply. So this is for demand. Then now we move on to supply. So with supply, with supply, they're saying that the supplier only begins supplying oranges when the price reaches 30. All right. So if it doesn't reach 30, they don't supply. So it means that here I have my price is 30 and then my quantity is 0. And then this explains why the graph of supply starts on the price, on the x-axis at P, you'll see. And then here the statement says the supplier increases supply by 20 bags for every 10 rand increase in price. So meaning that the change in quantity for every change in rand. So this part gives us the slope. So meaning that the slope is the change in 20 bags over the change in rent. So this gives us the slope. All right. And then now let's go to the questions. Number 1 says determine the demand function. So we all know that the standard form for a demand function is Q is equals to A minus BP. That's the standard form. This is the standard form for a demand function, or this is the formula for demand function. All right, the linear function for demand. And then for us to be able to solve for this, you must always look for A and B because A and B are your constants. That's what we look for. All right. So we have to calculate the slope. We always start with the slope. All right. So we know that the slope, which is B is equals to the change in Q. So it's Q2 minus Q1 over P2 minus P1. So let's see if we have two prices and two quantities. So if you can check, I already did that. I have the Qs, I have the Ps. All right. So now we are going to say my Q2. So it means that now we have this. Every time when you write the coordinates, it's because your P is dependent. We start with P. So it's always P, Q. All right. So not always, but it depends on the function. So now let's see. I have my price. On my price is 0. My quantity is 120. And then you'll see when my price is 60, my quantity is 0. So I'm just using the colors to show you. Not really important. So this will be, I got these from the statement under demand. So it means that I'm going to have Q2. So if I choose 120 to be Q2, so it's going to be Q2 minus Q1 will be the 0, the green one, then over P2, it's 0 minus 60. So the answer here, we are going to get, this will give us a -2. But because already on our formula or on our function, we already have a negative, you are not going to write this B as a negative because if you substitute this -2 into this formula or into this function, you're going to get a positive. And remember that the demand function must be negative. So therefore, this is not going to be a negative. We're going to change it to be a positive. So I'm going to say my B is a +2. So that when I put it here, it doesn't change this negative sign. Right. So I have my B. Now I'm going to solve for my A. When you solve for A, you use any of these coordinates. Either you use 0 and 120 or you use 60 and 0. You choose one. You can't use both of them. So I'm going to substitute. So I am going to have, remember, my function is Q. So I'm going to use 120 is equals to, it's up to you what to use because I want to solve for A. 120 is equals to A minus my B, it's 2, and then my P is 0. If I use 120, I must choose 0. Then this will be 120 is equals to A because this whole thing is going to give me A 0. -2 times 0 is 0. All right, so now we have our A, we have our B, then therefore we can conclude and say the demand function, the demand function. So therefore my demand function is Q is equals to my A, I got 120, then minus my B, I got 2P. The only two things that you have to look for is your A and your B, using your P and Q. So the most important things, parameters, are these two that we have to look for us to be able to find the function. All right. And then now we move on to the following question, question number 2. Question number 2 says that determine the supply function. So when we determine the supply function, remember we have to write the standard form of a supply function. The standard form of a supply function is, standard form Q is equals to C plus, it's a plus, the positive slope, plus dP. So now we also have to look for the slope for this one. So if you can remember, we already found the slope for the supply function. This is the slope because it says the supplier increases supply by 20 bags for each, sort of for every 10 rand increase in price. So this is the slope, change in quantity over change in price. All right, so it means that now our slope, which is D, is equals to Q2 minus Q1 over, okay, there's no need to write this because I already have the slope. So my slope is going to be 20 over 10, which is equals to 2. Right, and then now we have to look for C, so we substitute. So if you can remember, we already have, the Q and the P, which is 0 and 30. All right, so we are going to have, we already have our Q and P. My Q is 0, and then our P is 30. All right, so we're going to substitute into this. So we are going to have 0 is equals to C, because we have to look for C. And then this will be plus, our D is 2, and then our price is 30. All right, so this will be 0 is equals to C plus 60. Then we take this 60 to the other side, it's going to be negative. So this will be negative 60 is equals to C. So it means that my C is negative 60. Then therefore, my supply function is going to be Q is equals to C, which is negative 60. And then plus my D is 2, then P. So this is the supply function. All right. And then now we move on to number 3. Number 3. So number 3 says, calculate the quantity demanded when the price is 20. All right, so now we need to calculate the quantity demand when the price is 20. So it means we are calculating Q. So this will be, remember, our demand function, it's Q is equals to 120 minus 2P. And then this will be Q is equals to 120 minus 2. And then our P is 20, right? Then my Q, quantity demanded, will be 80 bags when the price is 20 rands. All right. And then now we move on to number 4. They're saying calculate the quantity supplied when the price is 50. So because it's quantity supplied, it means I must use the quantity function, linear function. So this is Q, supply, not linear, supply function, sorry. Q is equals to negative 60 plus 2P. Then I'm going to substitute. So this is Q negative 60 plus 2. And then my price is 50. So when the price is 50, so let's see, quantity demanded will be how many bags? 40 bags. When the price is 50 rand. Okay. And then now we go to number 5. I hope this corresponds with the law of supply that says that, because the direct relationship, it says that when the price increases, quantity supplied increase. When the price decreases, quantity supplied decreases. Okay. All right. I hope it corresponds. And then now we go to number 5. Number 5, it says that sketch the demand and supply curves on the same set of axes. So now we need to sketch. Sketch meaning we don't draw up to scale. So before we sketch, I need to write every information that I have. So let's start with the demand function. So under demand, our function is our function is, if you remember, it's Q is equals to A minus B P. Oh no, we already have the value. Sorry, it's Q is equals to 120 minus 2P. And then with this one, we have the coordinates. We have 120. No, it's 0. Price goes with 120. And then number 2, it's 60 price, 60 rands, that goes with 0 quantity. So this is what we have under demand function. And then under supply, let's see. Supply, we have Q is equals to negative 60 plus 2P. And then the only coordinates that we had is 30 rands, 0 quantity. All right, so this one is for this one. This one is for supply. So now we can plot our function. We need these to plot our function. So we're going to have okay. So when we start with the demand function, okay, so all of them, the quantity is dependent. So Q is the side, quantity is dependent, and then price is independent. Okay, we know this is 0. And then our intercept for the demand function is 120. So my graph is going to touch here. My graph is going to touch the Q here at 120. And then also touch here at 60. So these are the 2 coordinates anyway. At 60. And then I draw the graph. This is 0 and 120. This is 60 and 120, by the way. Those are the coordinates. All right. And then now we draw the supply. Supply, it starts at, sorry. So this is negative 60, but this one we draw a dotted line. It's not really included. This is negative 60. This is where negative 60 is at. Just an example. So this is a dotted line. So my graph is going to touch P at 30. So this is 30. Okay, I'm going to try to draw. But okay. Okay. Let me redraw this. Okay. Oh, sorry. I'm going to try. I made a mistake here by removing this. Okay. Let's do it again. Gosh. Okay. All right. Yeah, as I was saying, let me put it here. So this is negative 60. It's just and then my graph is going to start here at 30. 30 and 0. It starts here. All right. We don't include this negative part. So this will be the graph of supply. Will look like this. So this is supply. And then this one is demand. This one, the red one, this one is demand. And in this point here, on these two graphs where they are equal, we call it the equilibrium point. Equilibrium point. And in some, they say it's a market clearing price. So there's no shortage, no surplus at this point. So these two graphs are equal at this point. All right. That's it. I hope this helps. If it doesn't, you will have a tutorial. Thank you.